Hello. Sorry, I'm not very well again. I will bring myself in for tomorrow regardless. So please come. But I thought I'd do this one online, so maybe less chance of sharing my bugs and yeah, not feel a bit rough. So I'm gonna do continuous random variables. Hopefully, Alan's been in and he has given you the continuous random variable booklets. If not, just pause this video until you've all got them. Um, we want you to have a booklet. Well, if you want one, you can have a booklet. But before we do actually the work from the booklet, I've got this. It says it's a mini test. It can hardly be a mini. It's a bit of fun, isn't it? And all these questions, they're not really tests. These are two questions from the last topic we did. It says they're 10 marks altogether. What I'd like you to do is have a go at those two questions. On a piece of paper somewhere, not written big whiteboards, because then you'll be cheating. Not that it's a test. And see how you get on individually. If you're really stuck, I suppose you'll spy at somebody else's work anyway, regardless of what I say, because I'm not here watching. So have a go, and then we'll mark them in the end. Might not give you a full 10 minutes, might just give you the length of one of my songs if it records well. Now, we're going to moving on to statistics. Continuous random variables is what I'm going to start with today. As I said, we've got that booklet. So I thought we'd have a Christmas stat song. I know it's not on this topic, histograms. Um, I would say I think you'll enjoy it, but I'm not sure you will. I'll let you start this test. The song will play in the background, hopefully not too loud, and um, and then we'll crack on with the lesson.
To draw a histogram, first find each class limits, then use these to subtract. draw a histogram, first find each class limit, then use these to subtract to find each bar size width. Now using frequency, divide this by class width, will give you the magic height called frequency density. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more. To find the histogram, first find each class limit, then use these to subtract to find each bar size width. Now using frequency, divide this by class width, will give you the magic height called frequency density. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more. To draw a histogram, first find each class limit, then use these to subtract to find each bar size width. Now using frequency, divide this by class width, will give you the magic height called frequency density. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more. To draw a histogram, first find each class limit, then use these to subtract to find each bar size width. Now using frequency, divide this by class width, will give you the magic height called frequency density. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more. Oh, histograms, histograms, area gives a score. An equal scale and a title will tell us so much more.
Here's the answers. If you can mark your own, or you want to swap with the person next to you, and they will mark it for you. Did you get it right? You maybe not did it from first sort of principles like I've done here. You might have just used the formula and got it straight to that in about 2 steps, which is okay, but yeah, probably not worth 5 marks that way, but it's fine because I didn't say you had to do it from first sort of proof. And the second question, here's a second question. Yeah, maybe a bit harder. Completing the square. Yeah, hope you got all the marks then. So that was the first one, was probably pretty easy if you use the formula, just shoving in the numbers, and pick the right one. And then this one maybe slightly harder because it had that thing on the top that we didn't want. We needed 2x plus 5 and there was 2x plus 7, so you had to do that little trick. Hope you managed. Right, so we start some statistics. I think we should. Sorry, I have to blow my nose. Right, continuous random variables. We've got to recall the difference between discrete and continuous random variables, know what conditions a probability density function must satisfy, to know what a cumulative distribution function is, which is that big F below, and it's always the probability x is less than or equal to something, and to know how to change between the two using calculus. Right. Move on. Can I move on? Here's it won't let me. It says under there, sorry, only polynomial integration will be tested. That's probably a lie. Well, I'm not saying probably a lie. I know it's a lie. Hope it doesn't say it on your sheet. That was the old syllabus when we'd only just doing that. No, they can ask you to integrate almost anything now. Won't let me move. Right, we've had enough of that one. Next slide. Oh dear. Right, if probability density function, if little f of x is a PDF corresponding to a continuous random variable x, then the following probabilities must hold. Remember, we're talking about probabilities, so they will all add up to 1. So the area under that curve will add up to 1. Let's pop area in. F of x is always greater than or equal to 0. We can't have negative probabilities, so your area is always above the x-axis. The graph will never dip below. And that's just saying if you want to find the area between two limits, then that actually finds a probability that the continuous probability it lies between those two limits. Probabilities correspond to area under a curve. There we go. The cumulative distribution function, like the discrete Poisson and binomial distributions we have studied previously, it is often helpful to be able to calculate the cumulative probabilities quickly. That's the less than or equal to ones. The Poisson and binomial both have cumulative tables and calculator buttons, as you well know, PCD and BCD. But for this general continuous distribution, we don't have a button. We've got to use integration. So to get to the cumulative distribution from the other one, we just integrate. And to get back from our cumulative distribution to our probability density function, then we differentiate. So it's great we use a bit of calculus. There again, highlighting this fact that the cumulative distribution is the probability x is less than or equal to something. So we integrate between whatever bottom limit we're talking about and that number there. That will give you like x is less than or equal to 10, if that was a 10 there. But we want that to vary in our function, and then we can plug in any number and get any value there. This probably, let me put back on pen. These diagrams, there's a normal distribution. We know that's like a continuous distribution, and that's what the continuous distribution of that would look like. At the start, you have very little probability, and then by the time you get to there, you've seen half of the probability, and then the other half of the probability comes from the other half of the diagram. So cumulative distributions, the probability will get up to 1 and stay at 1, because that's what probabilities add up to. Good things for the cumulative distribution: if you put the top limit in, it will be 1. If you put the bottom limit in, it will be 0. To obtain the big F from the little f, we integrate, and obtain the little f from the big F, we differentiate. Like PDF to CDF. A continuous random variable x is defined by the probability density function, that thing. Now on my slides, you have double brackets just because my I was writing these, it wouldn't let me just do one bracket. Generally just do one bracket there. Right, we've got to sketch the probability density function. Well, it's not that hard. It's the graph y equals 1. So, and it's between 2 and 3. I nearly did it from 0 then. Terrible. Right, let's put 2 and 3 on there. So it's going to be the graph y equals 1, f of x equals 1, between 2 and 3. And 0 otherwise. There we go. So we've sketched it. Determine the form of big F. Right, to get big F, we need to integrate. So our big F of x, we will integrate between the bottom limit. Always the bottom limit. Bottom limit in this question is a 2 and a variable factor x. And we're integrating f of x, which is 1 dx. We can all integrate 1, I hope. So that's x, and then the limits x and 2. So if we stick in the limits top take bottom, we get x take 2. So how we write our big F of x out? Massive bracket. We always have to say, well, it's 0 when it's lower than the bottom limit. It is x take 2 when x is between 2 and 3. And it is 1 when x has hit the top limit or greater than the top limit. That's saying basically what's the probability x is less than or equal to 5 will still be 1. Because it's seen, when you're at 5, you've seen all that area of 2 to 3, so it's already added up to 1. Notice that generally on big F of x things, they put the less than or equal to's inequalities on, whereas in the little f's they put the less thans. Doesn't really make that much difference, because in cumulative, you know how I showed you, well, I don't know if I've shown you actually, that the area of it actually equaling a value, you'll have seen in your normal maths, is 0, because it's a very minute, tiny area. So it's practically 0, so less than or equal to 2 is practically the same as equal to 2. Less than or equal to is practically the same as less than 2, because it actually equaling 2 is practically nothing. And you can see if you put in 2 into this equation, you get 0 anyway. Put 2 into that equation, you get 0. So, well, sketch the graph of waffling. Right, so it says we're going to have this, so I'll put big F here, cumulative distribution. Oh, I should put X there. X there. Right, now we've got 2, got 3, and above it. So at 2 it's nothing, and at 3 it's put in there 3 take 2, it's 1. You wanted to put a value in between, 1.5. See, it's 0.5. So it's actually a straight line going up like that. And when it gets to 1, it stays at 1. Oops, that's not looking like it's going up. Stays at 1, and it's 0 before. So 2 and 3. And that stays at 1. Flattens off that. There we are. Better. Right. Hope you've got that down. Question 2 might be slightly harder. Let's see. A continuous random variable x is defined by the probability density function. Right. Sketch little f. It's going to be a curve because it's an x squared. K over 27. My word. Right, between limits 0 and k. I put 0 in there, I get 0. If I put k in there, what will I get? Well, I get k cubed over 27, wouldn't I? Because the x we're putting as a k. K cubed over 27, and you should know from graphs that will be one of them. So that's my little f of x. That's a curve, not a straight line. Not much else we can do at the moment. We know that area under there would be 1, so you could mess about and try and find what k is, but not for now. Leave that for a little while. Determine the big form f of x. So we got to integrate it between its lower limit. The lower limit this time is 0 and a variable factor x. So integrating this thing will give me, you probably know, I hope you know. What do you think? So I won't lose anyone. Not that I'd lose you lot, you're too clever. X 0. They really pulled the k 27 out because it's a constant. Right, so if we put in x and 0, you just get that function, don't you? K x to the 3 over 27 times 3, and 27 times 3 is 81. Oh, there's somebody at the door. So we've got that. That's our cumulative distribution. It's still got a k in it, and we've been asked to find the value of k. What we do know, as I say on a previous slide, that if you stick in the lower limit into the f of x, you'll always get 0. And if you stick in the top limit into the f of x, big F of x, you'll always get 1 because probabilities always add up to 1 and stay at 1. So the top limit here was k. So if you put k in, we know we get 1. So if I put k into this big f of x function, I would get, that's k's now the x. So I get x to the, k to the 4 over 21 and 81. And I know that that equals 1. So that leads us to find what is the fourth root. You rearrange that of 81. You put that in your machine, you'll find out it's 3. So k is 3. So we could write our big f of x then with k as 3. 3 over 27, which is, what's 3 over 27? I think that's 1 over 9 if I can do maths. Debatable. 1 over 9 now. X to the 3. Oh, what are you doing, you idiot? To rub that off. Let me rub that off because that's silly. No, I can't bother to re-record this, but apologies. All we're doing is putting in 3. That's my k in this one here, so that would make 3/81 next to the 3. Right. Okay, and you can cancel that down, I do know. Right, so it's 0 when x is less or equal to 0, that when it's between 0 and 3, and 1 when it's greater than 3. Drawing the picture, hurrah. No, at 0, it's 0, and funnily enough at k, which we now know is 3, it's going to be 1, and it's going to stay at 1. Oh dear. So that's big F of x. Didn't like stay at 1. That's it. And it's no longer quadratic, it's a cubic. It actually will be more like that slope. There we go. That's that question. I'm gonna make a mess of that, haven't I? And that bracket shouldn't be there. Right, let's try the next question. Oh no, it's one for you. Great. I'll give you a couple of minutes. I won't play any more silly songs. You're all right. Just give me a bit of quiet and see if you can do that one. Okay, are we done? There we are. There's a sketch of little f of x. Did you get that right? When it's 1, it's 3/8. When it's 3, it's 5/8. 0 otherwise. And then determine the big F of x. You integrated that thing. Now it all depends whether you used chain rule or whether you integrated them separately and what version you got. I used chain rule there. But you might have got that black answer there by not using chain rule. And then writing that out in the correct form, you can put that black answer where you've probably got the black answer there. Right, and then drawing the picture, you can see that's a curve, so it's going to be a curvy curve here between there, and then it gets to 1, it stays at 1. Lovely. I hope you got it right. I won't say put your hand up if you got it right, because I can't see you. It would be pointless. Right, moving on. This time we're going the other way around. Can we hold in the excitement? Let's see. A continuous random variable is given by the cumulative density function big F. Oh look, there's my computer, won't like that bracket. This thing. Find the value of K and then find the PDF. So finding the value of K, we've said before, if you put in the top limit, that's the top limit, it will give you an area of 1. So if we put 3 in there as our X, we know that will equal 1. So that's 8K equals 1, therefore K equals an 1/8. Done. Nice. So done part A. Part B, find the PDF. So this time we're going to have to differentiate. So if we differentiate, that's with an 1/8 there. So I'm basically doing d dx of this function here, which was an 1/8 of x minus 1 to the 3. So I'm differentiating that, and that will give me, I will use chain rule, 3/8 x minus 1 whole squared times the differential of the bracket, which is 1. So that's it. How we'd write that out in the end then, we have to do our little f of x equals whirly 3/8 x take 1, 0 otherwise. And this is between 1 and 3. Only 2 blocks on that one. Hope you like that. There might be one for you next. See. Off you go. See if you can do that one. Mini whiteboard, not big one. Right, we're done. First of all, finding the K. Oh, surprise, it was an 1/8 again. And then B, can you differentiate that? Well, let's see. You're differentiating it and you'll get 2/8 x take 0, because an 1/8 goes to 0, and that leaves you with 1/4. You must write it out like that. Don't just leave it as 1/4. You will not get all the marks. You must set it out like that. It is important that we set it out in the bracket with the 0 and the otherwise on. Okay. The note says you can do 1 and 2 from the worksheet, but I'm going to plod on and then you can just get on with the worksheet after. Tricky one, is it though? Let's look. Continuous random variable x has as defined by little f of x. Oh, it's got 2 sections. Oh, goodness me. Right. Sketching it's going to be a little bit harder. Right. Let's get a scale started. No. 1, 2, 3, 4, squeeze on 5. There we go. Right, between 0 and 1 it's doing nothing. Between 1 and 2 it's doing that. So put 1 in, you get nothing. Put 2 in, what do we get? 2 take 1 is 1, 2/3. It's quite big. It's linear, so it'll be a straight line joining that and that. Put 2 into that other one and we'll still get 2/3. Good, there's no discontinuity. And then we'll put 4 in there and we get 0. So we made a popular shape called the triangle. We all knew that. And then we've got note otherwise as well, because it's on the little f of x. Right, part B, find big F, big F. Oh. Right, we've got to do big F in some little, in proportion, well, not in proportions, in stages this time. So little f up to there is nothing, up to 1. Now between 1 and 2 we're going to have to integrate that bit. So it's the cumulative distribution. This is the big word here that'll come into play in a minute. Cumulative, running total. So between 1 and 2 we see nothing up to 1. So between 1 and 2 we're just going to have to integrate between the lower limit 1, a variable factor x, and we're integrating that first function 2/3 x take 1 dx, which gives me, pull the constant out, x squared over 2 minus x, and I'll put on my limits x and 1, stick in x, take away when we stick in 1, I have to go up into this space up here. Right, so we're going to write that neater. Should we write that neater? Just on this with chain rule, it would have looked a lot better. Never mind. I'll write it like that. So I'll multiply it all through. So that's x squared over 3 minus 2/3 of x, and then this thing, that's minus, that's plus. That'll be a half, wouldn't it? So is it 1/3? I think it's that. There we go. What we agree. So that's the cumulative between 1 and 2. Now the cumulative, remember, running total between 2 and 4 is governed by a different function. But because it's cumulative, you always add on at the start the area we've seen before. So in other words, we need to find out this area here and add it on when we start at 2. So basically that's putting the top limit into this function here, or working out the area of that little triangle-y shape there. So let's have a see. So between 1 and 2. So we want the total area up to x is 2. So in terms of thingies, that's big F of 2, because remember it'd be a big F of 2 equals the probability x is less than or equal to 2, because it's a cumulative function. plus lower limit 3 varying factor 2 varying factor x of that second part of the f of x, little f of x there. So what was the area of that thing if you put 2 in? Well, if I remember correctly, which I probably don't, well, that little triangle, what was it? I've forgotten the function. Let's see what I'll write it here, I have it somewhere. No, so it was a third, putting it in here already, third x squared, was it minus or plus? It was minus 2/3 of x plus 1/3. Let's hope it was that. Right, so if I was to put 2 into that, that would be 1/3, this is f of 2. 1/3, oh, not 4/3, minus 4/3, add a third, so that's a third. Right, so we've got 1/3 there, add on this new thing, integrate. Put in the x. Put in the 2. Does that come to then? What have we got? We've got a third here, and we've got 6/3 there. Oh, I hate mental maths. 6/3 minus 2 is, well, I like having you there to do this for me. Minus 2 and plus 1/3 is minus 1 and minus 5/3, isn't it? Yeah, stick that there. Right, and I've always got a negative squared thingy there, and that's a 6, so I don't like that. That would be minus, I hope I'm getting this right, 6, and then add, I did this in my notes, I did it all in, I did it all in reverse chain rule, so it looks a bit different, but here we go. Right, so this is this. I might pull out a third, or I might not bother. I won't bother because I'll make more mistakes. So that is what it is between 2 and 4. And the way to check this to see if I'm right is put in 4, and we should get 1. If I don't, it's completely wrong. So if I put in 4, let's do that over here in a different coloured pen, so you don't write this unless you want to. F of 4, so that would be minus 4 squared, which is minus 16 over 6, plus 4 times 4 again, 16 over 3, minus 5 over 3. Have I got a calculator? Shouldn't really need a calculator, but there we go. Not very well, that's why I have to use a calculator. Wouldn't otherwise, of course. Wrong Can't believe this. How can that be wrong? Sorry, long pause there, it was ridiculous. Of course it's right. My calculator's not working. Well, I say that's me pressing the buttons, isn't it? Right, so that's all fine. If you put those in your calculator, you will get 1. Can't believe I took that long. Right, let's move on swiftly. Oh, just to say that, yes, you must put the note on here and the 1 on there for less than or equal to the bottom limit, bigger than or equal to the top limit. It says now, all complete worksheet 1 and 2, and attempt 3 and 4. So you can get on with work. Oh, right, summary here. So to find probabilities, find the area under the curve integration. We've met, we know that the area under the curve of the little f of x is 1. The PDF is a probability density function, and the big F of x is the cumulative distribution function, which is your less than or equal to your PCD button for cumulative integration, for cumulative distribution functions. Let me start that, for continuous distribution functions. So to convert between the two, integrate, differentiate. Hope you've understood today's lesson. Pull the correct face at your friend, and hope they're pulling a similar one and it's not the last. Right, all the worksheet questions are now for you to try are in your booklet, following lesson 1. So hope you manage to get on with them, and don't get too stuck. I said I'll bring myself in tomorrow because I've got some medicine that's helping and working, and I shall see you all tomorrow to wish you happy Christmas. And yes, and I'd like you to get on with that. Maybe there'll be one more tune unless someone stops this video very shortly. And yeah, hope you get on well. Bye. Here are some answers for some of those, something on the worksheet. I think I'll just leave those up. Hope it plays a little song while it's going. See you tomorrow.
I wish you a Merry Christmas, I wish you a Merry Christmas, I wish you a Merry Christmas and a Happy New Term. To pass the exams you have to revise, so stuff the chops and turkey, get pen and notes out. I wish you a Merry Christmas, I wish you a Merry Christmas, I wish you a Merry Christmas and a Happy New Term. To get a grade A, 10 questions a day throughout the festive season, and you'll be on your way. I wish you a Merry Christmas, I wish you a Merry Christmas, I wish you a Merry Christmas and a Happy New Term. To pass the exams you have to revise, so stuff the chops and turkey, get pen and notes out. I wish you a Merry Christmas, I wish you a Merry Christmas, I wish you a Merry Christmas and a Happy New Term. To get a grade A, 10 questions a day throughout the festive season, and you'll be on your way. I wish you a Merry Christmas. I wish you a Merry Christmas. I wish you a Merry Christmas and a Happy New Term. Merry Christmas to all, and equations be with you.